We're switching gears and moving to talking about waves. So away from electricity and magnetism and into properties of waves. You do not have this book with you, so you will need to review this PowerPoint and other PowerPoints for this chapter. The objectives of this PowerPoint are how are waves classified and what are properties of waves. So when we think of waves, we're obviously probably our minds are going to like the ocean. And this isn't the type of wave we're talking about, but that can give us a good visual. So the waves we're talking about are not visible to the naked eye. Okay, this is any disturbance that transfers energy from one place to another. Okay, lots of things give off waves. Anytime you see light, that's in waves. Anytime you hear a sound, like my voice, it's causing a disturbance and it's transferring energy to your ear from my mouth. Okay, so waves move through a substance. The substance is called a medium, and some mediums waves move through easier than others. Okay, these are called mechanical waves. The waves transfer energy through the substance, but they don't change the substance. So a good visual of this is a duck sitting on a wavy pond. Okay, the duck might move up and down as the waves flow across it, but the duck is not actually moving. Okay, he doesn't move within the pond, he just moves up and down with the waves. So there's three main types of waves. We have transverse waves, which transfer energy up and down. Okay, so you'd be moving this string as a visual, you'd be moving this string up and down, okay, and your wave is going to move like this. That's called a transverse wave. So you have an up and down motion, if you will. Another type of wave is a longitudinal wave. Okay, this transfers energy from side to side. So you have things called compressions. So think like an accordion. Okay, you have a separation here, and then it moves together here. Okay, we call this part a compression, and where they spread out is a refraction. Okay, so these are moving kind of like an accordion. That's a longitudinal wave. And then you have a surface wave. Okay, these take both of those up and down and side to side movements, and so it moves in a circular pattern. Okay. There's lots of vocabulary words that go along with diagramming a wave. Again, this is technically an ocean wave, but it's a good diagram to help you. So let's talk about the vocab with that. So one of the words is amplitude. So that's the distance from sea level, if you will, okay, to the highest point. So that's that movement. Okay, a wavelength is the distance between two crests. A crest is the highest point of a wave. The opposite of a crest is a trough. That's the lowest point of a wave. And frequency is the number of complete waves that pass a given point in a certain amount of time. So when we talk later on about light and sound, frequency is very important there, and how quickly the frequency of these waves is going to affect what you hear or what you see. Okay, frequency is measured in hertz, which is labeled capital H, lowercase z, hertz. Okay, calculating speed. We can use the equation wave speed equals frequency times wavelength. Again, wave speed equals frequency times wavelength. So in the discussion board for today, you need to answer these two questions. You're welcome to use a calculator using this equation.